Evet değerli Art TV izleyenleri, bugün 2 Ekim 2022 senesi ve Art TV'nin bilimsel gündemiyle devam etme niyetiyle bugünkü seansıma başlıyorum. Birkaç gündür yayınlarımızda NASA'nın DART projesi hakkında e, çeşitli makaleleri çevirerek, bunları yorumlayarak bir umumi değerlendirme yapmıştık. Bunları şimdilik bir kenara bırakalım. Yine bilimle ilgili bir başka konuya geçelim. Şimdi internette fevkalade ilginç ve fazla bilinmeyen bilgileri veren bazı bilimsel belgeseller var. Daha önce bunlardan birini çevirerek sunmuştum. Astrum adlı sitenin Alex McColgan'ın anlattığı belgeseli sunmuştum. Yine öyle bir nitelikli bir çok ilginç bilgiler veren bir belgesel var. Bunu da e, yine uzayla, fizikle, astronomiyle ilgili son gelişmeleri de değinerek e, ilginç bazı bilgileri neredeyse sıcağı sıcağına veren Anton Petrov adlı kişi sunuyor. Bu ilginç bir belgesel ve takriben 15,5 dakika sürüyor. Benim niyetim bunu çevirmek ama öncelikle bunu bir bütün halinde buraya aktarayım. Ondan sonraki seansta belki e, azar azar durarak sindire sindire çeviririz. Şimdilik şöyle bir şunu sunalım.
And today we're going to be talking about our sun. And as the title of this video suggests, we're going to be seeing our sun as we've never seen it before. Mostly based on a lot of new imagery and a lot of new observations that came out in just the last few months from two specific telescopes or observatories. One of them is right here on planet Earth in Hawaii, Inouye Solar Telescope, and the other one is in outer space, slowly approaching the sun, the ISIS Solar Orbiter. And in the last few months, both observatories have actually released some incredible data that we've never seen before, and some really impressive pictures, or actually even videos. And so in this video, we're going to take a look at some of them, with a lot of the imagery that I'm going to be showing you only becoming visible to us because of the incredible new technology that these telescopes use. But one of the main reasons I actually wanted to make this video is because of this very recent announcement coming out of NASA, and specifically out of the telescopes observing the sun, that announced a detection of an extremely powerful solar flare, or solar emission, or essentially an explosion coming from the sun, produced by the sunspot that you see right here, that the scientists currently think is one of the most powerful, if not the most powerful, ever detected. Although luckily for us, it was not headed toward our planet, it was not headed toward Earth. It was actually headed toward Venus, and it might have hit Venus, while at the same time also hitting the ISIS probe, the Solar Orbiter, or SOLO as it's known, the probe that actually started operating only in 2020, but is expected to produce a lot of incredible data about our sun, and is most likely going to help us understand how various solar eruptions work. And today, naturally, that's an extremely important topic for the reasons of the technology we use on the planet. If a solar eruption occurs and we're not ready for it, there's unfortunately an extremely high chance that we're going to experience a major blackout in a lot of different sectors on the planet, and it might actually cause tremendous damage to the current civilization. We've discussed some of these ideas in some of the videos you can find in the description. And so by trying to study these eruptions and trying to understand or even predict them, The modern scientific studies are actually hoping to find a way to prevent a potential disaster on the planet, which is why today we have more and more missions observing the sun and trying to learn as much as we can. But even though these missions have just started and have only been operating for just a couple of years now, they've already been able to take some incredible pictures of the sun and have already been able to provide us with a lot of intriguing data. And very recently, NSO, part of the National Science Foundation, released some of the observations from the Inuit telescope in Hawaii, with the images showing us things that we've never really seen before. Incredible images of the surface of the sun. But first of all, what exactly are we going to be looking at? So normally, the visible surface of the sun, the photosphere, is what we actually see from planet Earth. In this layer, the photons produced by the sun escape through the transparent solar atmosphere and become the sunlight or the solar radiation. And in this case, the visible light we see is produced by the electrons as they react with the hydrogen atoms to produce hydrogen ions. But there's another layer that's usually invisible to us, known as the chromosphere, that's generally visible as a kind of a colored flash at the beginning and the end of the solar eclipse. And this layer, the chromosphere, is extremely difficult to see, but there are so many things the scientists want to learn about it because they believe it also kind of controls the upper layer, the corona, the layer that you mostly see visible in white. And so the modern telescopes have been developed to try to perceive these layers by applying various filters. And now, for the first time ever, we kind of get to see what the chromosphere actually looks like. This is one of the first images from the telescope in Hawaii showing us the chromosphere of the sun. Although in this case, the resolution of a single pixel here is about 18 kilometers, with this entire image being roughly around 80,000 kilometers across. Something that's invisible in these previous videos and previous images because they were observing very different spectra and very different light. And one of the most important features that the scientists want to understand are the bright-looking hairs that represent plasma controlled by very powerful magnetic fields underneath. And all of these hair-like formations form these unusual structures that resemble, I guess, cereal or corn. These are known as granules, and each of them is roughly around 1600 kilometers or approximately 1,000 miles across. And I guess one way to try to understand the scale here is by putting planet Earth. These are definitely huge structures, with each of these granules and each of these hairs being almost as long as the entire planet. Here's the comparison of granules next to planet Earth. And this is an important first step for the scientists studying the sun. Being able to see the chromosphere was always one of the biggest challenges for many of the scientists, representing an entirely new era for solar physics. By observing and studying the chromosphere and connecting it to the other parts of the sun, the scientists can now predict and prepare for various solar storms in ways we could not do so before. And so definitely an important first step in helping us predict solar weather much better than we ever could, possibly days or even weeks in advance. And actually this is also something that's extremely important for the future of space exploration as well. Any potential craft traveling across the solar system, and that includes any mission to Mars or the Moon, is going to have to be prepared for any potential solar weather, but also has to rely on the predictions from planet Earth for potential solar storms. Because as we know from various studies on the International Space Station, a major solar storm can actually cause major havoc for any spacecraft or any colony on the Moon or on Mars. So studying all this is super important. But that's of course why ESA has its own mission as well, with its own observations and its own capabilities of seeing the sun in a very different perspective. The solar orbiter has already provided some incredible insights into, for example, how our sun changes magnetically on the inside and how it shapes space weather. And not so long ago, it also provided some incredible videos and incredible pictures of the features we've never really seen before. And at the moment, this particular orbiter is the most complex scientific lab ever sent to the sun. It has some of the most complex instruments and some of the most advanced instruments able to study the magnetosphere, the ultraviolet radiation, the solar wind, and well, actually quite a lot of other stuff as well. So this is a super complex probe, with the main focus currently being the study of the movement of various charged particles associated with the solar magnetic field and the particles that usually create space weather. Now, around March of 2022, it was at its closest approach to the sun, inside the orbit of Mercury, and approximately a third of the distance of the sun to planet Earth. Its heat shield reported temperatures of about 500 degrees Celsius, and during that time, its 10 scientific instruments, with 9 led by ESA and 1 being NASA instrument, started to work together, observing various things in our sun. For example, during that time, it passed through several solar flares and even a coronal mass ejection that was actually directed toward our planet. providing some of the first observations of these unusual events so close by. And during this time, it observed what you're about to see on the screen here. It observed some really unusual features that the scientists have never seen before. One of them they started to refer to as solar hedgehog. It's the feature you can kind of see in the bottom third of the image. And currently this actually has no explanation and nobody knows what exactly is forming this. Very unusual, very strange, but very likely produced by some kind of an interaction with the magnetic field. In this case, this was only observed at the ultraviolet 17 nanometers in wavelength, and despite this appearing kind of small, it's actually pretty big. As you can see, it's larger than our planet, approximately 25,000 kilometers across, with the gases that are coming out of here also being super hot, around 1 million degrees, way hotter than the actual surface of the sun. Once again, why? Nobody knows. It was also lucky enough to catch one of its first solar flares at an extremely close distance to the sun. This happened on March of 2022. And in this case, this resulted in a major solar flare that was then visible in the corona of the sun. And as you can see, as you kind of move away from the picture, it kind of gives you a very different perspective of how extremely powerful all of this was. Now, this tiny explosion that you see here was responsible for producing one of the more powerful coronal mass ejections then visible from the distance. And in some sense, this exactly is what the scientists want to study. They want to understand how all this relates, how all this connects together, and most importantly, what's the actual mechanism behind these, and how we can predict them, or how we can protect ourselves from them then causing damage on planet Earth. And then it also got to take a picture, or I guess a video, of what happens at the solar poles. In this case, I guess you would refer to this as the southern pole. And in this case, when it comes to magnetic storms on the sun, the scientists believe the answer is actually probably at the poles. That's where all the secrets probably lie. All of the magnetic fields that create various types of active regions on the sun eventually get swept up by the poles before being swallowed back into the sun itself. And so this region is also extremely important for the scientists, and they want to understand it a little bit better. And specifically because they believe there's actually a kind of a cycle. The magnetic activity on the surface eventually gets distributed to the poles, goes inside the sun, restarting the cycle again somewhere close to the equator. And so if we actually see what's going into the poles, we might be able to predict some of the sunspots that may result in very powerful emissions later on. Although in this particular case, just being able to see the poles with so much detail is already quite incredible. Now, because all of this is actually only visible in the ultraviolet light, what you're seeing here are two different colors. The lighter areas are created by loops of magnetism that rise upwards from the solar interior. These are normally called closed magnetic field lines because a lot of magnetic particles usually stay inside when becoming trapped. But the darker areas are where the sun's field is open, and so a lot of gases can escape into space, creating solar winds. But because this is an extreme ultraviolet light at approximately 70 nanometers, we're not actually going to be seeing this with our own eyes. You do need to have a very specialized instrument. So something like this. But more importantly, some of the recent observations and recent studies have already been able to some extent, predict the appearance of very powerful emissions from the sun before they hit the craft, and then predicted them when they actually are going to hit planet Earth. In other words, suggesting that the spacecraft can definitely serve as a very important part in predicting solar weather, coronal mass ejections, and magnetic storms. And all this started when one of the instruments, the energetic particle detector, started to detect a lot of highly energetic particles coming from the sun. And this was detected as a major change in the solar wind and seen in different instruments. Although intriguingly, the more powerful particles, or the ones with higher energy, arrived much faster and were moving much faster as well, whereas the low energy particles were moving slower, presenting a kind of a telltale sign of an upcoming coronal mass ejection and a solar storm. And within just a few hours, similar disturbances were also detected in radio frequencies when various types of electrons started to be accelerated by the interaction with the magnetic field. And in this case, it produced a very specific type of wave known as the Landmuir wave, which indicated that energetic electrons have just arrived at the craft. And this by itself can already serve as an important sign for some of the future missions that are trying to predict very powerful coronal mass ejections, which can then result in major storms on planet Earth. And at the same time, the X-ray instruments were able to see something happening on the surface of the sun, possibly seeing the events responsible for the release of all these particles. These X-rays are produced when electrons accelerated by the flare interact with various types of hydrogen in the lower levels of sun's atmosphere. And so by seeing all these events all at once, it then becomes possible to not just predict the event, but to even assess its potential strength, and thus assess potential damage to planet Earth. Now, at the moment, it's still not clear how all these observations are actually connected yet, but that's exactly what this probe is for, and that's what these studies are for as well. And interestingly, none of the magnetometer instruments picked up anything until way later, and that's because the particles from the coronal mass ejection that often do carry charge arrived to this location much later, naturally suggesting that this is a very important step in predicting these events, because these powerful emissions seem to occur much earlier. In some sense, it's kind of like the modern meteorologists are able to predict the approach of a powerful hurricane by seeing the storm approaching by using weather satellites. And naturally, within just a few hours, the coronal mass ejection and all of the magnetic charge connected to it arrived at the spacecraft and was detected by the team, who then actually posted it on Twitter, warning planet Earth of the upcoming storm that's going to hit the planet. And within about 18 hours, the storm arrived, creating this beautiful aurora that you see right here for at least a couple of days, within 2 days of the initial detection. And so in this case, the scientists were able to forecast and predict this within approximately 2 to 3 days. But the goal here is to try to predict this even earlier, which is essentially the main point of this mission and the main reason for this telescope as well. But because all of these studies are still just starting and all of this is in its infancy, there are going to be so many new things we're going to be discovering about our sun in the next few years. And remember, as I've mentioned in some of the previous videos, by 2025, the sun is going to be at the peak of its activity. And as at least one study predicted in the past that you can find in the description below, there's actually a high chance that this particular solar cycle is going to be one of the most powerful on record, suggesting that we might actually have to prepare for a major storm in the next few years. You can find this video in the description below. But I guess until we learn something else, or until new discoveries, or new beautiful images we've never seen before, that's pretty much it. Check out all the relevant links in the description below, subscribe, maybe share this with someone who loves about space and sciences, come back to more to learn something else, and maybe support this channel on Patreon by joining channel membership or by finding the wonderful person featured you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye-bye.
Evet, şimdi bütünüyle bu ilginç belgeseli çok etkileyici görüntülerle beraber sunduk ama çevirisini sonraki seansta yapalım.